Welcome to part 3 of our trig lesson. Today we're going to look at finding side lengths of a right triangle given one of our angle measures. Look at our first problem here. Notice we have a right triangle, which is necessary. We have an angle of 64 degrees. We have x as a side and 25 as a side. Now, because this is a right triangle, we can do 180 minus 90, which is 90, and 90 minus 64 to get our third angle. But it's not necessary. We can use our trig functions to find this missing side using 64. Always be aware of what values you have for your sides. If you've got a hypotenuse, make sure that you identify it. Okay, so as I'm looking at 64 degrees, I notice that this side x is opposite of 64 degrees. And then, of course, this is my hypotenuse. So I actually have an opposite and a hypotenuse, which I know to be sine. So what I can do is I can find the sine of 64 degrees, and that is going to be equal to the opposite, which is x, over the hypotenuse, which is 25. Okay? This is the same thing that we've been doing, except this was theta. So we said the sine of theta was opposite over hypotenuse. Now we know what theta is. Theta is the acute angle 64 degrees. So the sine of 64 degrees is equal to x over 25. So in order to figure out what x is, I can very quickly multiply both sides by 25. And these two will cancel out, giving me x. Now to figure out what x is, I'm going to multiply 25 times the sine of 64 degrees. When you're using a calculator and you're finding degrees and you punch in 25 times the sine of 64 degrees, make sure your calculator is in degree mode. So mode, and then you'll see right here you've got degrees and radians. We'll be talking about radians later on, but for now, make sure your calculator is in degree mode. So second and quit. So 25 times the sine of 64 degrees. Well, look at that number. We don't want to write all that down. So we're just going to round everything to the 10th place for right now. Okay? So we'll have 22.46. The 6 will round the 4 up to a 5 to give us 22.5. So x, since I'm rounding, I'm going to put approximate 22.5. So this missing side length is 22.5 units. So right now what I want you to do is I want you to try number 2 and number 3. Pause the video and do number 2 and number 3. All right, let's see how you did. So, looking at my angle measure, 47 degrees, I notice I do not have a hypotenuse here. So that screams of tangent, doesn't it? I know that tangent is the opposite over the adjacent. So, tangent of theta, which is 47 degrees, is equal to the opposite, which is x, over the adjacent, which is 12. So to solve for x, we're going to do the exact same thing. We're going to multiply both sides by 12. And so x, these two will cancel out, and I'm going to use my squiggle signs again because I know I'm going to have to round. So 12 times the tangent of 47 degrees. 12 times the tangent of 47 degrees. See, 12.86, the 6 around the 8 up to give us 12.9. So x is approximately 12.9. Number 3, okay, this right here is my hypotenuse. So if I've got a hypotenuse, I want to use my cosine or my sine. So let's figure out what we've got. Here's my theta, 18 degrees. Opposite is blank. This is my adjacent. So I have adjacent and hypotenuse. So adjacent and hypotenuse is going to be my cosine. So the cosine of 18 degrees is equal to the adjacent over the hypotenuse. So to solve, I'm going to multiply both sides by 34. And so my x, these two will cancel out. And so I'll have 34 times the cosine of 18. So that'll be 32.3. Now let's look at number 4. This one's a little bit different. Let's see what's going to happen. So I don't have a hypotenuse. So once again, I'm going to use tangent. So here is 35 degrees. So tangent of 35 degrees is equal to the opposite, which is 9, over the adjacent, which is going to be x. Now this time, if you'll notice, that's going to put our x in the denominator, but that's no big deal, okay, because we're going to multiply by x to bring it to the numerator. So I'll have x times the tangent of 35 degrees is equal to 9. And then I'll just divide both sides by the tangent of 35 degrees. So, if you will just remember this setup, you can just take whatever is above the x and divide it by the tangent of 35 degrees, or whatever the case may be, and you're going to get your answer. Okay, so I have 9 divided by the tangent of 35 degrees. Okay, once again, let's go out 1 decimal place, and that'll give us 12.9. Okay, now I want you to look at number 5 and number 6 and do the exact same thing. I'll pause the video at this point, and when you're finished, mash play. So 63 degrees is going to be my theta this time. This is my hypotenuse, okay? So I'm going to use sine or cosine. With that being said, with the 63 degrees, this is opposite of 63, and of course this is the hypotenuse. Opposite over hypotenuse is sine. So we're going to do the sine of 63 degrees is equal to the opposite over the hypotenuse. So to find x, multiply both sides by x. And then divide by the sine of 63 degrees so that you can get x by itself. So we'll have 27 divided by the sine of 63 degrees, 30.3. Number 6, okay? Once again, I see this is my hypotenuse, all right? So with my hypotenuse, I'm going to use sine or cosine. So right here is my theta. This is opposite. This is adjacent. So I've got adjacent over hypotenuse, which is my lovely cosine. So the cosine of 30 degrees is equal to the adjacent over the hypotenuse. Now remember, you're going to multiply both sides by x, but what you're going to end up with is 18 divided by the cosine of 30. You can go through all of these steps if you would like, but if you will just memorize what you're doing here, it'll be a lot easier, okay? So 18 divided by the cosine of 30. Be 20.8. Okay, and that is finding side lengths given one side length and one of your acute angles. Finish your assignment, and if you have any questions, let me know.